Hi, I'm Rich with Inside HPC. We're here at PASC19 in Zurich, Switzerland. And today I'm here with Sunita. Sunita, thanks for coming on. I understand that you were a co-chair for the Papers program. Can you share some highlights?
Absolutely. So Umit from Georgia Tech and myself are co-chairs for the PASC technical paper program. And this year we had a wonderful set of submissions amounting to 34 technical papers, which is a fantastic number. And these papers span chemistry, climate, computer science and applied mathematics, emerging application domains, engineering, life sciences, physics, and solid earth dynamics. So this is what makes PASC very interdisciplinary, as you can see already. So among 34, we selected 17. And if you want statistics of the 17, we have 2 from physics, 7 from computer science and applied mathematics, 5 from climate, 1 from chemistry, and 2 from engineering.
So a broad swath.
Yes, absolutely.
What was the best paper?
Right. So the best paper went to Sam Hatfield from University of Oxford, and he talked about accelerating high-resolution weather and climate models with deep learning hardware. So I thought Sam gave an excellent talk, and he was speaking to the masses. He was an excellent speaker, and he spoke about single precision, double precision, half precision from a climate and weather modeling standpoint, and which worked for them, which didn't work for them, and he was trying to tell the audience of which way to go when you have certain types of problems. And I thought he did a fantastic job in communicating how to use the NVIDIA Tensor Cores, and how to apply his algorithms on those sort of systems. So so Sam is going to receive his best paper later today in our closing remarks.
Very nice. Yeah. Well, I wanted to ask you about, hardly seen you. You've been so busy because you also had some mini symposia this week. Can you tell me about those?
Sure. So I had 2 mini symposiums this year. One was co-done with Ann Custers from Jülich Supercomputing Center. So in the first mini symposium, it was OpenACC focused. As you know, that OpenACC has been used by several scientific developers to port their scientific applications to large-scale systems, which gave me this wonderful opportunity to invite 4 of those speakers to speak at PASC. This being an interdisciplinary conference, it cannot get better than this, right? So I had Lucas Arnold and Ann Custers as your first talk, which was on computational fluid dynamics, Juror, Juror, and I must point out that this is one of the codes that was part of a hackathon. One of the OLCF and OpenACC hackathons that's been happening across the globe lately, since past 3 years, I should say. So that was a code from the hackathon, and Lucas presented this work and talked about how OpenACC was applied to the computational fluid dynamics, followed by Gabriel Staffelbach and Geoffrey Legoff from Surfax, France, on the ABVP combustion code. So it was so well done because these speakers talked about how important it is to come up with a maintainable software, because somebody is going to write some portions of the code and that person may leave the organization or academia or what have you for future prospects, and somebody else might come in, so there's a lot of documentation involved, a lot of hands on one code. So it's going to go through several iterations, so you're better off maintaining something that is reusable and written once, right? So the message came through very well, and this was it was not planned that way, but it flew very well, which I thought was, very apt for the mini symposium. The third speaker is Rich Loft from NCAR, National Center for Atmospheric Research in Colorado, the US, where he talked about the famous PASC, which is a climate weather modeling code, experiences, performances, the status, and how the developers have been, porting OpenACC, using OpenACC and porting PASC to GPUs. It's been a couple of years' effort, and he was walking us through the several challenges and how they have overcome some of these challenges in order to do what they are intending to do. And the last speaker was Elge Noop from Hanover, who talked about PALM, which is another CFD code, and he talked about performance portability, and he broke down the functions of PALM, like which were easy to port, which were complicated to port, the do's and the don'ts, So a lot of takeaways from these mini symposium. So it was a very nice set of 4 talks that communicated to the audience how do you approach these kind of scientific problems, right? You profile, parallelize, optimize, fine-tune. So there are many steps because directives are, it's not magical to add directives to the code because you let the compiler do most of the job, but compilers are not, it's not magic because it's written by computer scientists and we are not magicians. The second symposium was on Thursday, which was MPI plus X. So there was a variety to the X brought in this particular second symposium, where it was OpenACC, OpenMP, CUDA, and Alpaca. And I kickstarted this mini symposium by giving a talk about accelerating prediction of chemical shift of protein structures using OpenACC. This is work done by 2 of my undergraduate students, Eric Wright and Mauricio Ferrato, who are now my PhD students. And I would like to say this is probably because of the fascinating work they did. With a lot of help from Alex Breyer and Juan Peria from Department of Chemistry and my former PhD student, Robert Searles. So this code, the crux of this code was bringing down the time taken of the most compute-intensive kernel and the entire code piece from 14 hours to 2 minutes. Wow. Not kidding, 14 hours to 2 minutes. Yeah. So a lot of fine-tuning, right? Yeah. And this is a function that can be called in several molecular dynamics workflow, which a function that will be iterated several times. So it's going to make a huge difference when you're going to iterate a function which is going to take 14 hours versus 2 minutes. The second talk in this mini symposium was from Paul Selwood from UK Met Office, and he had a very interesting title which says Ready, Thready, Go. OpenMP threats, right? And he gave a fantastic talk about OpenMP load balancing from a weather forecasting standpoint. And he walked us through the several different challenges in climate and weather modeling. And you would notice that in the PASC conference, there are many sessions on climate and weather modeling because it's a massive problem, right? And so he told us a lot about how to use, different types of balancing techniques and how that had an impact on his weather forecasting model. The third talk was from the Alpaca group from HCDR, Helmholtz Zentrum, Dresden Rossendorf, Sergei Bastrakov, who talked about write once, scale everywhere, using Alpaca for future-proof HPC kernels with architectures evolving as we speak. You having different backends is really awesome. So that's what Alpaca is all about. It's a C++ abstraction, but many different backends. And he focused on PyCon GPU, which is the scientific code from HCDR. The last one was by Yuichi Asafi from QST Japan, who talked about plasma simulation code from an MPI CUDA and MPI OpenACC standpoint. Again, he also walked us through where things went wrong, where things went right, which performed better, which performed not so better. MPI plus OpenACC did stand apart when compared to MPI CUDA in a good way, and he had his own theories of what went right. So yeah, those 2 were the 2 mini symposiums at PASC.
Okay. A lot of great work there. So along the lines, Sunita, of portable programming, right? Next week is ISC conference,
yes.
Right? And you guys have a workshop, an all-day workshop on Thursday at the conference, all about portable programming. Can you tell me about that?
Absolutely. This is a workshop which we call P3MA. And many different stuff goes into P3MA, which is performance, portable programming models for many-core, and many-core was something we added this year because of a lot of focus on many-core and accelerators, right? And this is co-organized with Swaroop Popole and Arghya Chatterjee from Oak Ridge National Lab. So we have papers on this workshop, which is going to be held on June 20th, Thursday. It's a full-day workshop. And performance tuning, programming models, and I have a panel as well. I have 2 keynote speakers from Mitsuhisa Sato from Recon, as well as Simon McIntosh from Bristol. So morning and evening, 2 keynotes, and I'm really looking forward to all the cool things they're going to tell us at the workshop. I have a panel on the same day at the end to conclude the workshop at 3 p.m., where I'm so grateful to these panelists who have agreed to be on my panel, which is C++ Sickle Morris Hafner from Codeplay, Christian Trott from Sandia on Cocos, Sergei Bastrakov from HCDR on Alpaca, Michael Wolf from OpenACC, Sato San from Recon on the architecture, and I'm awaiting confirmation from one of my OpenMP colleagues. There are many of them. I'm waiting for one from one of them. So the panel is going to be on programming models playing catch-up with evolving architectures, accelerators, and many core. So I'm very much looking forward to it.
Well, hey, Sunita, thanks for coming on, sharing with us, and really looking forward to those workshops coming up at ISC. So,
Absolutely. Thank you so much.
great job.